Hey everyone. So today we'll be starting with this new technique, which is two-pointer approach. So this video will be mainly for beginners, or if even if you are intermediate. So this can be helpful for you. It will help you to identify on which types of problem you should really aim for two-pointer approach. Although two-pointer approach is something that is pretty much intuitive on its own. If you get some problem, you can directly think of two-pointer. But while I was solving this coding problems and all, let's say 8 to 10 months back to get my this job, so I was pretty confused. I can admit that I was confused on many occasions, that even for other person or any other student, this two pointer is intuitive, but for me it was not. So here I'll be telling each and everything, targeting especially the beginner ones. So let's get into it. So basically in two pointer, first of all, you should be knowing that two pointer means not something special. It's just two variables. If I say, you can call them any, let's say L and H. So what will happen in look, there are many ways of it, but they are not entirely different. See, mostly it will be your array. So let's say this is your space where you have to find your answer, and in this space, whatever answer you have to find searching or doing any other stuff, traversing this array, whatever that may be. If there is a way you can start traversing, look, mostly the solution will be order of n square. Mostly the solution will be order of n square. Why is it? Because for every index you have to go every other index. For every index you have to go every other index, which means for inside for. All right, for inside for. So this is what normal template will be for brute force. And when you will see this brute force, you will get the hint that if I can start from the extreme points, let's say I can start from the extreme point, I can keep two variables here, and I can, on depending on certain conditions, if I'll move L and H, which means this to right, H to left, if I can move them, then the complexity will be reduced to order of n. All right, order of n. So this is the first thing. See guys, there are many more things I'll be telling. Be with me in this video. All right, then in a bit of tweak in this traditional one, you'll be, let's say, given in this sort of array space. So now what may happen, and you'll easily find templates for this, like find the middle of a linked list and all those stuff, remove middle of linked list, and what is that, circular point, the point from where the linked list is being cyclic. So this template will be used a lot, this particular problem, for this particular way. So what it says, so for to find any to find, let's say, to find solution for the problem, if you require the sort of thing that one here, see, here the two pointers were at extreme ends, and it is not the only case. I have seen many students like who are in touch with me. Many times when I ask about two pointer, they generally say, "Bhaiya, two pointer means we go from extreme ends." No, it's not that. It's not always true. Mostly it is, but it is not always true. So what happens in many cases, you may start your L and H from the same point. You may start your L and H from the same point, but the condition would be, out of these two pointers L and H, one will move slower, like one will go faster than other. A faster in sense, it may go like, look, L can go L plus plus, H can go H plus equals to 2. All right, double the speed, or even H plus equals to 3. It depends on the certain problem. Mostly it is H plus equals to 2. So this is the second way. The third way would be L and H. It is not necessary that L and H will start from same location, like the starting point, or L and H will start from extreme points. It may be possible that L and H may start at some distance. They will start at some distance, and they will move simply L plus plus, H plus plus. All right. So these three are like, and why I told about these two, because I think they are not like that required, because we can directly figure it out seeing the problems. But this misconception I have seen in many students, that two pointer means coming from extreme ends. No, it's not always the fact. It's not always true. Now see, there are a few other things. This is what you'll directly get on internet and everywhere. But there are a few other things that like I would like to share from my end. Okay, while solving thousands of problem on like several platforms, Podge, LeetCode, GFG, this is the common thing that I've got to know. See, in your brute force, let's say you are given this array space. Mostly two pointer will be applicable on array. It can be on ranges, but right now let's consider the example of array. Don't say me कि भैया आप सिर्फ array पे ही बोल रहे हो. No, it is applicable on many other things, but mostly it is on array. All right. So if in your brute force, look, brute force can be of many ways, but if in your brute force you are using, let's say, an array, and if you can get your solution, by dividing this array into two sub arrays, two different arrays, I can say. So what I mean by this, in your brute force, if you are seeing this solution, if you are able to get a solution, see guys, in brute force, if you are able to get a solution, and what is the condition? The solution is you are thinking that if I divide this array space, into two parts, into two different array, and if I traverse from this array, this array separately, I'll get my answer. So here comes the simple logic of two pointers. So one pointer for this array, one pointer for this array. Look guys, after this introductory video, our initial few questions will be on this concept, because this is widely used, like dividing your array space into two parts. And see guys, so in your brute force you did this, right? You divided this. Look, obviously you'll get your solution in order of n time mostly with this, but you are using extra space. You are dividing this array space into two parts. If in your brute force you are doing this sort of thing, see guys, if in your brute force you are doing this sort of thing, that you are kind of dividing your main array into two different arrays, which means you are using extra space just for your answer, and that too like two extra array. So what we will see in the coming questions, that it is not required, the division is not required like this. We can handle them by if or else conditions. Okay, so what I'm saying is, dividing them into two extra array is good. It will give you answer, but it is not optimized. Why? Because we will see the problems where it is happening like this. There we will get to know that if we write proper if and else, we will directly handle. See, as in binary search, if you watch my binary search playlist, you know how I divide zones into favorable and unfavorable spaces. We don't create a new space. Only if and else, using if and else block, we know that the initial part is favorable and final part is unfavorable, or vice versa. And see guys, here if you remember this, that in our binary search, what we did in binary search, we never divided this space into two physical. See guys, here in this, what I said, this array space is divided physically into two parts. It is divided physically into two parts. In binary search, we never divided anything physically. All right, if you have watched my videos part 1 and part 2 of binary search, we never divided this space into two physical arrays. Here in brute force, we will divide into two physical space, and so this is one of the differences. So obviously, because many of you can get confused that by binary search, maybe तो आप ऐसा ही करते थे, दो space में divide. But at that point in binary search, we never divided that into two physical different spaces. All right, never into two physical array spaces. At the same time, in binary search, what we were doing, we were searching for one element. We were searching for some element. We were searching for that. We were not see here in two pointers, you will not search for an element, you will iterate, you will do a traversal. You can get many elements. In binary search, your motto was to get one unique element, or I mean one element. That is why it is called binary. It is called searching. So here you are traversing. You will traverse. There's a difference between traversal and search. Traversal, you will go from one index to every other index, and you'll get certain answers. So there may be many answers. There may be many pairs. All right, there may be many such values that you have to return as an answer. In binary search, there was no there was one and only one answer that you were searching for. So this is the difference. See guys, so here you are dividing it into two physical. First thing you have to see that you are dividing into two physical spaces. The array need not to be shorted and sorted. It is random. Consider this as random. So, and how is it different from binary search? First thing, in binary search also you divide into two parts, the main space, but not physically. Here you divided them into physically two different spaces. You'll divide them into two physical spaces, and one iterator here, one iterator here for this array. This is why you're using two pointers, and this is why you'll go for two pointers, thinking that one pointer for this, one pointer for this. But in binary search, the conditions was it was sorted, you were searching, and then you were not dividing into physical two spaces. All right. So consider this also in your mind. In this way, the differences also between two algorithms itself. And the other thing, and it will also be used. See, it is something like it's not that easy to like directly find like which technique is used. Obviously, if you have a bit of experience, let's say 3-4 months on these problems, I'll share these things. The intuition behind two pointer is pretty clear. But if you are beginner, see guys, if you are beginner, there were problems. When I was beginner, if someone says on this sort of problems, you have to go for two pointer, I was like, how can you figure it out? How can I figure it out? So here I'm telling you the secret. See, the problem is like target sum. There may be problems on two sum and water with most container with most water. There are many problems on this on basically on the top of this problem. So what it says, you are given an array space and you are given a variable k equals to 7. So you have to give me all the pairs. You have to give me all the pairs whose sum is 7. Pairs mean two elements. Okay. Now see guys, first of all, this is sorted right now. It may be sorted or unsorted. You can sort it, but right now it is sorted. All right. So what will you see? Forget about brute force. Forget about everything. Just see your test cases and you see your test case and see your answer space, what your answer is. See, if you can see, if you start from, see, normally in brute force what we do, if you're given an array, you will start from left to right. Normally you will start from left to right. In few cases you start from right to left, but here let's start from left to right. Okay, we need not to worry about anything. Let us start from left to right. So what will you see here? That if you start from left to right, let's find all such pairs. So here I have wrote down everything, every possible pair. I may have missed one or two, but mostly I've written 3, and I found 3. So see, this index 0. Look, I am writing I and j. Okay, these two indexes will depict what? The pair that will give me 7. All right. So if you see here, see, -1 and 9, it's not giving me, but then see, with -1 you wanted 7, right? So something x plus -1. All right, so x will give you what? 8. So you want 8. -1 8. Is there 8 present? Obviously 8 is present, and 8 is present at which index? Index number 9. So in this way, if you go right, you see 0. For 0 you want 7. 7 is present at index number 8. For 1 you'll find 6. 6 is present at index number 7. And when you move on to like this, no other pair is possible as I can see. So I and j, you can write this way, I and j. And now see guys, it is, look, in coding, while doing tons of problems, it is not required that you learn algorithm and data structure always. No, the motto should be to start observing things from a simple sheet of paper, simple numbers, and get the patterns. All right. So see here, if you can see guys, in this solution, the behaviors of I and j, I is going from left. I can say I is increasing, always I is increasing, while j is decreasing. And see, j has potentially j is starting from final index. All right. See, final index is 10. Obviously it is starting from 9, but what I'm saying is it is starting from the last part. It is starting from the extreme end, that is the rightmost end. All right. So, and I is potentially starting from leftmost end to get the answer. So I can say I, generally people call it L and H, but right now just for convenience I'll say I and j. So I and j are starting from here and here. All right, see guys, again in this problem the brute force will be order of n square. Why? Because uh, let's say for 0 index you got that it is -1. To get sum equals to 7, I need an element who is 8. So what you will do, you will again, because it is an array, you will again start for this -1, you will search 8 in this array. In the same way, you will search for every index, you will go to every other index. So in this way, the solution is order of n square. But here, if we see, if we see guys, for 0 you got 9, then you moved one step, then you moved one step, like you're moving some steps. So directly by seeing the answer space, forget about solution guys, directly by seeing answer space, a bit of hint, a bit of idea can be that solution is possible in order of n time in one traversal itself, not more than one. You don't need any square traversal, you can get your answer in n, only one traversal, order of n. This is just idea. If see guys, if it is not kicking inside you right now, no problem. Yeah, it took me months for this. See, I'm not pro right now. Even I'm not pro. I'm just learning things, because I have solved like more than 1,000 problems, so I have the idea of it. So if you're beginners, if you're intermediate, it will take time. Yeah, it will take time. Be consistent. That's it. Be disciplined. It will take time, but I can help you in this journey. This is what I'm here for you. I'm not providing anything new, because before me and after me, people will come. There already are there who are like way ahead me in terms of teaching. But what I can offer, I'm doing my best. I can, because I'm just me. I'll make sure that people of my caliber, who are dumb like hell, they get to know everything. At least what I know, I make sure that they should know this, and that is why I'm just simplifying whatever thing I know. So see here, you got to know that you got this idea that I and j probably they are starting from the extreme points. This is the hint that you got. Now let's see here what actually they are doing. So if you see I and j, let's calculate. -1 plus 9, what is it? What it is giving me? 8. Do you want 8? No, you want 7. See, if your I was here, j was here. Now you see, if you move I to right, which means -1 will increase further. So if -1 will increase further, the entire sum will also increase. So it will increase from 8, but you have to decrease. So what, you cannot move I to right now. See guys, because we want answer for every index, so we got to know that -1 and 9, they cannot be paired together, because this is what we saw in brute force, and we will see this problem later as well. But just for the sake of understanding, be with me guys. So -1 and 9, you got this, that if I improve -1, if I increase -1, why, and when your sum of these I and j is greater than 7, let's say here, if I increase -1, this I index, if I increase, I know this sum will be increasing from 8 to 9, 10, whatever that may be. So I cannot increase I can increase the I index, but I need a lesser value than 8, which is 7. Obviously I need a lesser value, so I'll decrease j, because you see j was decreasing. So I'll decrease j to one index, which is, it will go to 9. So -1 plus 8, now it is what? It is 7. So you can see here, depending, see guys, this may not be that intuitive right now. For those who have somewhat experience, for them this is pretty intuitive. But for those who are beginners, I know I can feel that you are not getting everything, especially on this page. But if you are getting this idea, that in your answer space, if you see your I is going up, your j is going down, then also you can think in a way that, because if, and see, after certain point, see guys, after certain point, if you see this I and j, after certain point, what is happening actually? It is happening that I and j are not crossing each other. See, which means they're not repeating. See, it started from 0, 1, 2, and it started from 9, 8, 7. No, it's not like in reverse way, it cannot go, that it will go from, it will have 9 and it will have 0, because index number 90 you already got. So if you're getting just this idea that I is going, I is marching, I and j are marching towards each other, which means that here also the 2-pointer technique will be used. And how it is used, you will be seeing problems while solving this sort of problems. You will get clear vision. But I hope these few things are clear to you, that 2-pointers does not only start from extreme ends, It is not only about slow and fast technique. It may these 2 pointers may go only one step at a time, but starting from a distance LNH, there may be a distance, and this thing is widely used, that in your brute force, if you can divide the array space into 2 parts, and if you traverse them separately, which means you can go for 2 pointer, and this one is pretty normal. So do let me know in comments, guys, if you got this idea and got this intuition that how to use the 2 pointer technique. Do let me know in comments, that it will really help me. Chalo, bye bye.